Okay, this is Don Davis, um, part two of the scale development analyses, and we're going to look at confirmatory factor analysis. Um, so, I'm not going to go through how to do this in this set, but there's a little bit of work that has to happen just to get the data from an SPSS file into a DAT file. So this is the type of file that MPlus reads. And I can kind of give the short version. So um, in SPSS, you have to make sure, um, so I'll usually enter missing data as 999. I think it can handle some other things, but you can save your file as a tab delimited. That's a DAT file. It's going to put the variables across the top, which you then have to delete. So I always save my SPSS file so that I can actually look at the exact variables that were in the file and recreate the DAT file. And then we're kind of up to part two, create a syntax file. The MPlus manual has a lot of this, but if you've got someone who's already created syntax, it's pretty easy to just adapt prior syntax. So you can leave notes for yourself. Anything after an exclamation point doesn't get read. So this is the communication sacred file. This, as long as your input file is in the same file as the data, you don't have to put the full address. So we can see that this is the file name. And then you list your variables. So this is a shortcut. Names are, and then C1 through C13. You can name that whatever you want. And then you have to end every command with a semicolon. If you forget that, MPlus kind of freaks out. Then you have to tell it which variables you're actually using. So in our case, we dropped 9, 10, and 11. So we're not using those. These are some kind of standard defaults telling what missing data is. We're using MLR estimation, blah, 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 blah. And then this is the part that has to be somewhat adapted. So the format here is you're naming the factor by, these are the names of each item that comprises the factor. So you can put the semicolon either up here or down here. And then these are, this is kind of a standard line of what output you want. You can get a lot of more technical stuff as well. So when that's ready, you hit run, and it gives you all sorts of output. So you can kind of go through and check to make sure it was reading the file properly and that there seemed to be the right number of cases. And then what we're most interested in is we're gonna look at this CFI and RMSEA. So rule of thumb, if this is above 0.95, that's really good. Usually we want to see this below 0.06. Definitely above 0.08 means there may be some problems. I found most of the time with scale development, as this creeps up, even if some of the other fit looks good, it usually means that you have some items that are correlating with each other more strongly than they should. So because of similar wording or something like that. And that's what we find here. So when we go down to the modification indices, items 2 and 3 are kind of, they're related to each other more strongly than you would expect just based on the latent construct. So a good way to test this would be for us to go in, do this before I forget. So what we end up doing is we're going to drop item 3. And then we're going to check the fit again. Okay, so the CFI, after we drop item 3, and to do that, you just delete item 3 from the use variable in the model. I'm going to leave a note, drop item 3, to remember what we did. Oh man, a lot better. CFI 0.99, RMSEA equals 0.01. We've really overfit here, but we'll see on the replication sample if it continues to be good. So close that down. Okay, so I've kind of already set up our replication sample, 182 people input file. And I checked to see this, so I had kind of already dropped those items before I replicated it. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then there's 9 variables in this set. So in this case, on the replication sample, we've got a CFI of 0.91, RMSEA of 0.12. That shows some indication of problems again, and my guess is, once again, it might be issues related to redundancy. It's kind of what we talked about earlier. Our alpha is really high. So it looks like particularly item 3 is kind of it's correlating more strongly with 1 and 5 than we would expect just based on the latent construct. So what if we dropped item 3, C2, C4, C5, C6, C7, C8, C9, and let's drop that in, okay. So a little bit better, 0.95. CFI equals 0.95, RMSEA. This is still a little high, 0.10. So we could, again, looks like 1 and 5, 8 and 9. So let's see what 1, 2, 3, 4, 5, 6, 7, 8. I just enjoy sitting and talking. So let's try dropping 8. 0.97, 0.08, that's closer to what we're looking for. So again, we kind of overfit. And so this didn't go quite as smoothly as we might want, but we've generally got a set of items that are loading on one factor, and to some extent we probably could justify dropping some of the items, particularly ones that kind of share fairly similar language. and it would probably help our MSEA kind of consistently